Hello and welcome everyone. Thank you so much for joining us for the VOR MON webinar. I am Leonixa Salcedo, the VOR MON Program Manager. I have been with the Federal Aviation Administration for 21 years, and I currently work for the Air Traffic Organization's Program Management Organization. Here with me, I have two of my colleagues, Vince Massimini and Rick Niles, and I also want to give them a chance to introduce themselves, starting with Vince.
Okay, hello, my name is Vince Massimini. I'm an old guy. I'm a former military pilot. I flew the A4 Skyhawk, and I'm an active flight instructor and own a couple of GA airplanes and have been working on navigation aid right sizing for about the last 25 years with the FAA. And what we'll be talking about today is some of the results of that specifically for the VOR MON. Now over to Rick. Here we go.
Hi, I'm Rick Niles. I also have been working on this for quite a while. I'm an active flight instructor as well, aircraft owner, experimental aircraft builder. And I've worked with the FAA for about 20 years on navigation work. And Vince and I have worked on this particular problem for quite some time. And we're excited to tell you about it.
Thank you, Rick, and thank you, Vince, for the introductions. Before we start, I want to remind everyone that we will have a Q&A session, so please remember to submit your questions using the Google link that you can find on the live stream page. And with that, we can go ahead and start. So I'm going to start off by providing you a high-level program overview. In 2006, the FAA started the transition of the National Airspace System from conventional to performance-based navigation. Of course, we call that PBN. Now, PBN is enabled by the Global Positioning System, GPS, and it does not require the use of VORs. Now, that doesn't mean that we can remove all the VORs from the NAS, but it does mean that for the contiguous 48 states, we can repurpose the current VOR network to a minimum operational network. And that would be to provide a backup service in case of GPS outages. The first time that the FAA published their intent to do this was in 2011, and we used the Federal Register in order to do that. And you can see the information there on the slide in case you want to go to the Federal Register website and pull out the details. But what I want to let you know is that the intent was to receive comments from all stakeholders, and also after we received the comments from everyone through the FRN, we wanted to formalize a little bit more of the process on how to develop the concept of operation, the criteria, our schedule, and even get recommendations like the outreach that we're conducting today. In order to do that, we coordinated with the RTCA Tactical Operations Committee, the RTCA TOC. So that gave us, created some working groups with the industry and other stakeholders, including other government agencies. After we did the coordination to make sure that our plans were good and they were improved and the best and most efficient ones, we finalized our policy. So in 2016, we also used the Federal Register to let everybody know that we had completed our policy. And again, the information is there. You're going to find the process for discontinuation. You're going to find the criteria. You're going to find the details of what I just explained, of who we work with and how we did that. And lastly, in the FRN, you'll also have a target list of VORs that are planned for discontinuance. I'll tell you a little bit more about that later. But for now, I do want you to know that the program has two phases. Phase 1 started in 2016, and it completed in fiscal year 20. By the end of phase 1, we discontinued 82 VORs. Phase 2 started this fiscal year, FY21, and is planned to complete in FY30. The idea there will be to discontinue another about 200 VORs. So there's two main things we have to provide as a service in order to have this VOR MON. So the first one is that we are going to be providing continuous VOR signal starting at 5,000 feet above ground level. In order to do that, we have published 2 new VOR standard service volumes, and they can be found in the Aeronautical Information Manual, the AIM. Again, more on that from our experts later in the briefing, but for now, what I want to let you know is that we're going to fly every VOR. We're going to conduct flight inspection on every VOR that will be getting the new service volumes before we publish those. we are planning to start publishing the individual VORs with the new service volumes by the end of this calendar year 21. The second most important requirement that we have for the program is to have what we call MON airports, and they are pretty much already on the charts, but I want to tell you a little bit about what they are. What we want to do is provide a way for you to land utilizing a purely conventional approach, and you don't have to fly more than 100 nautical miles from any point in the contiguous 48 states. So if you are flying GPS and you lose signal and you have to revert to VOR, you will find a MON airport not farther than 100 nautical miles. So again, more on that from the concept of operation as our experts brief later, but I just wanted to let you know that's our second most important criteria for the VOR MON. Lastly, any VOR that is not needed to meet those two criteria, and there's some other criteria that our experts will take you through, those are the VORs that we call are targeted for discontinuance. And now, why do I keep calling them targeted? So even though we have a national plan or a plan specifically for the CONUS, for the contiguous 48 states, we do follow the standard processes. So the FAA has standard processes for the discontinuance of NAVAIDS. In this case, of course, we are specializing on the VOR discontinuance itself. So in order to do that, every single VOR will go through what we call a non-rulemaking study. That allows a chance for anybody in the public, other government agencies, industry, to provide feedback on the proposal for the discontinuation of that VOR. Once we receive that feedback, there's a committee within the FAA with a lot of experts, including air traffic, and they will make an analysis and determine whether we can continue with the plan of discontinuing a specific VOR. Once that is done, once that is completed, then we start putting mitigations in place. I'm going to give you one simple example of a mitigation, but VORs are very complex, so there's a lot of things that go into it. But one example would be a conventional procedure that is canceled may need to be replaced with a PBM procedure. That's not always the case, but as an example, if that was required, we will put the PBM procedure first before we turn off the VOR. So by the end of this process, all the mitigations will be put in place first, and then we'll discontinue the service, and all the databases and charts will be updated. In this slide, I just wanted to give you a very high-level picture, and a visual picture of what the program looks like in the CONUS. So here in green, all the dots in green, they are referring to the VORs that we're planning to retain. And all the dots in yellow represent the VORs that we're planning to discontinue between now and FY30.
Okay, so let's talk a little bit about the concept of operation of the VOR MON, why we're doing it, and also how we developed the VOR MON. So first thing is the MON is here because I think we all know that GPS can be interfered with or jammed. And if it's jammed, we obviously won't have it. Now, we're not talking about the GPS constellation all going away for months or years. What we're talking about is more of a localized event, maybe as large as a couple of 100 miles, and also probably not for more than a few hours or maybe a day or two. So we're trying to give the users some options if this happens. And the options that we're given are really two. If you get in a GPS outage or you're in an area with a GPS outage, one of the things you can do is tune and identify a set of VORs. That's the VOR MON VORs. And you can tune and identify that VOR and fly VOR to VOR at least 5,000 feet above the ground. And you can go through the outage, okay? Or if you can't make it through the outage or you want to land somewhere, then you can navigate VOR to VOR to an airport that has an instrument approach that you can shoot with a VOR or an ILS receiver. And that all of the VORs for that approach are going to be retained. Now, one of the glitches about the last few years is that the FAA, many small users don't maintain distance measuring equipment, DME, or automatic direction finding, ADF, and those are not maintained. So the approaches that we can shoot to these airports don't require those. Also, the approaches don't require surveillance, and naturally they don't require GPS. So how did we develop the VOR MON? The first thing we did was said, well, look, 5,000 feet AGL sounds really good, and pretty much everybody can fly there, but that's not necessarily true out in the Western Mountainous area. So most of the VORs are being kept in the Western Mountainous area, particularly the VORs that run you down valleys and things like that. We also retain VORs to support international oceanic routes. And those are principally the routes that come in from the Atlantic and the Pacific. We're not really retaining VORs for Canadian and Mexican routes since they're doing their own VOR reductions. Then we retain VORs to navigate to these instrument approaches that we can do at an airport we can land at. Those instrument approaches are an ILS, a localizer, or a VOR approach, and it'll be within 100 miles of pretty much anywhere in the continental United States, conterminous United States. But it'll be an airport with an ILS, VOR, localized approach, and that approach won't require ADF, DME, or surveillance or GPS. All right. And then in a couple of cases, we had to maintain some additional VORs in order to get the complete coverage at 5,000 feet AGL outside of the mountainous area. All right. Rick is going to show you in just a second all of this in pictures, so it might be a little bit easier to understand.
Yeah, this is inherently geographic, so being able to visualize it is very important. So I'm going to go through each of these 4 steps in graphical pictures of the lower 48 United States, so that you can see how it progresses. So this first picture is going to be these first 2, the Western Mountain US and the international routes. So this picture here shows the Western Mountainous designated area for the United States, and we've preserved almost all the VORs in that area. And then over here on the east, you can find a handful of VORs that are anchor points for oceanic international routes. Now, we didn't always maintain ones that go to Canada and Mexico. It was really these oceanic ones that might have been more complicated because they involve other countries to dismantle. So this was the initial set we start with. And then on this next step, we're going to identify the airports that have these approaches that Vince was talking about. The idea is, again, we want an approach that ideally an ILS with vertical guidance, but if we can't have that, we'll do a localizer. And if we can't find one of those, we'll do a VOR. So what we've done here is we've identified these airports and put 100-mile circles around each of them in green that have either a ILS or a localizer approach. Unfortunately, as you get out into North Dakota and Montana, there aren't as many ILSs, so we had to use VOR approaches. And then in Northern Nevada, there wasn't actually any approaches that satisfied our criteria, so that's just the way it is today. But the idea is in most of the populated US, we will have a ILS approach that you can get to within 100 miles as shown on this chart. And what we're going to do is we're going to keep all the VORs associated with that approach. So there's 3 elements you have to have. You have to have an initial approach fix, you have to have a final approach fix, and you have to have a missed approach fix. And those have to be identifiable with a VOR or the localizer without relying on the DME or the ADF or radar vectors. So when we add those VORs, this is the picture you get. So we've got a whole bunch more VORs, including the Western Mountainous area, but now we've got all these that are supporting these approaches. And this is the coverage at 5,000 feet using a new service volume Vince will tell you about in a moment. But there's still some gaps here at 5,000 feet, and we promised 5,000 foot coverage. So we strategically have chosen additional VORs in this next picture that generally fill in those gaps in coverage. And we've also identified a few extras around major metro areas that are going to help ATC to handle the congestion of a large number of aircraft if everybody was out of GPS at that time.
All right, so let's talk a little bit about this new service volume that Rick mentioned. As many of you know, the service volume now for a VOR below 14,000 feet is only 40 miles from the VOR. It turns out that that restriction, that 40-mile restriction, was not really based on the power of the VOR transmitter or the sensitivity of the airplane receiver. It was based on co-channel interference from other VORs. So with quite a bit of work, came up with the idea of extending that service volume from 40 miles to 70 miles at 5,000 feet. Now, below 5,000 feet, the service volume is still going to be 40, but above, it'll go out to 70 nautical miles. And what that does is really improve the coverage at 5,000 feet. So the slide that's coming up right now is, this is the coverage of VORs before any VORs were taken out. So this is several years ago. But the service volume is a 40-mile radius for each VOR. And you can see from the east central US all the way to the west, there's a huge number of gaps in VOR coverage. This is at 5,000 feet AGL. I was pretty surprised about this when we started working on this. But with the extended service volume of 70 miles, we take out VORs, and this is the coverage we get. So this is coverage with about 300 VORs taken out of CONUS, but the service volume extended. So in terms of service volume coverage, the VOR MON is actually providing better coverage than the full set of VORs.
So let's talk a little bit about charting. How is this going to be seen on your charts? So on the left over here, we have a high altitude chart, and on the right, we have a low altitude IFR chart. And what you'll see is the MON airports will get a inverted MON above it. So in both cases here, we have Green Bay, and you can see the MON written above the airport. That tells you that that is an airport that has an approach that does not require that additional equipment that a lot of people don't have, including Vince and I anymore in our airplanes, which is DME and ADF. That's distance measuring equipment and automatic direction finders. So now exactly which approach it is, you have to go and look it up, but it's available for you if you're in IMC weather. Now, the other way you can find it is in the chart supplement. The chart supplement has a complete list of all the MON airports. The last thing I'll mention is we don't have it listed on the VFR chart, the VFR sectionals and terminal area charts, because VORs are primarily a function that's used for IFR traffic, and they're electronic means of navigation in the case of a GPS outage. And the idea is if you're VFR and if you can see well, then you should be able to land at the nearest airport or navigate using pilotage or dead reckoning and not need the MON necessarily. You're free to use it as a VFR pilot, but the service is primarily for IFR pilots. Now, other services that VORs use, they primarily serve this function of providing you an azimuth to navigate off of, but there were a couple other uses that we had to mitigate. So DME is associated, or TACAN, with a lot of the VORs, in fact, most of them. Because of other needs for air traffic and air carrier navigation, we are preserving most of the DME sites. And so the charting will appear, this is a VFR chart sectional on the left and an IFR sectional on the right. And you see the symbol will just be a square. So that's a DME you can tune in if you still have that equipment, but there's no VOR associated with it. And if you don't have the advanced equipment to receive multiple DMEs and compute your position, it's not of all that much use to you, but you can use it as a reporting point. Next is flight service communications. Many VORs allowed you to talk to flight service stations, FSSs, by using something like 122.1 to talk to them while you listen on the VOR frequency to have two-way communication. The idea is we already have good coverage of 122.2 across the country and 122.3 in much of the country, where you can talk to flight service station, and that was deemed adequate through a study that we have sufficient coverage of those frequencies that we do not need to backfill the VORs that are being discontinued. Finally, there was AWOSs and ASOSs. Those were automated weather observatory systems and automated surface observing systems that you get local weather for at the airport. Those services occasionally were located on the VOR receiver. Those services will be relocated to a discrete COM frequency and in those few places that it was used. The last thing I'll mention is there was a use of HIWAS, which was an automated recording of area weather on VORs that you could listen to in the past, but that service has now been discontinued. So that's not a service we needed to worry about relocating. And Vince is going to tell you a little bit about changes to requirements.
Okay, so the big question that often comes up with this is, well, the FAA is keeping this VOR MON, which is really a pretty good deal because almost everybody that's flying IFR anyway has a VOR in their airplane. That's a good deal. But so what changes in terms of requirements? Well, the good news is that basically nothing is changing. If you're flying under Part 121, which, Part 91, which most of us are, there's no change in your filing requirements, in your alternate requirements, or in your fuel requirements. Okay, so you want to fly and not worry about the VOR MON until something happens, that's fine. But obviously it would be a good idea if you kept in mind that if a GPS event happened, you might have to go navigate VOR to VOR or go to a MON airport. But there's no requirement to do that, okay? Now, just to review, aircraft that have a non-WAS GPS, so not the no wide area augmentation system, these are the original GPSs that come out, you are still required to carry an alternate form of navigation, such as a VOR, for your route of flight. You also have alternate filing requirements, either at the destination or the alternate. So if you have a non-WAS GPS, you still basically have to carry a VOR or some other navigational aid as a second form of navigation. However, if you have a WAS-capable GPS, you don't have to carry any additional navigation except for your WAS receiver. And that's not going to change with the VOR MON. Okay. Now, a little caveat here, people who fly airlines under Part 121, air taxi under Part 135, or fly fractional ownership under 91 subpart K, those folks have different requirements for navigation and backup. And those are generally generated by the Certificate Management Office. So not everything I said about Part 91 is necessarily true for airlines, air taxis, and fractional owners. Now, another thing that's going to happen is airways are going to change. What happens is, I didn't know this until I started working on this, but a Victor airway, a V airway, or a Jet airway, a J airway, must be anchored by a VOR. Well, guess what? We're getting rid of a bunch of those VORs. When the VOR goes away, at least that segment of the airway has to be removed. Now, I don't know about y'all, but I hardly ever use airways except when I'm in a real dense ATC environment. I just go direct. So this is kind of a good thing. As we remove VORs, some of the airways are going to go away. All right. Now, not all of them can go away because air traffic control needs them. So in the case of where air traffic control needs an airway, then what will happen is we'll create a GPS-based airway, a T route or a Q route, and that'll satisfy ATC's need to structure their traffic. Okay, next slide. And just what you can see, this is already happening. If you look in the center of this diagram, that's really Cleveland Center, Lake Erie's right up above. You can see that in the center of the diagram, pretty much all of the airways are gone. Well, what happened is Cleveland Center that controls that airspace said, there's a bunch of guys named Massimini out here that are just going direct and they're not using those airways. So why are we keeping those airways? So in this case, ATC did not need the airways, so they just removed them. And even before the VORs were going. So this is kind of the future of airways, where we're going to see airways being reduced, and where air traffic control needs an airway, you'll have a T route or a Q route, but otherwise you'll have no airway. Now, in the Western Mountainous area, lots of the airways are still remaining because we kept most of the VORs out there, and it's hard to fly at 5,000 feet above the high mountains.
So in summary, the purpose of the VOR MON is to switch the primary function of the VORs from being the backbone that define all the routes in the NAS to being kind of the emergency backup for potential loss of GPS. And the users will be able to navigate through the outage or land at a MON airport without the use of GPS, without the use of distance measuring equipment, automatic direction finders, or surveillance coverage. So it's a nice safety backup, and GPS users not equipped with GPS that still want to use the old-fashioned stuff to navigate can still operate the NAS, but they're going to have reduced efficiency because we're going to have less VORs. However, it's not that bad because, as Vince briefed, we're going to have much bigger service volume. So even when there's not a route published, you'll be able to fly VOR to VOR much easier throughout the NAS. There's no changes to the current equipment or flight planning requirements. So you don't need to get a new receiver or change any receiver. You don't need to worry about adding additional time to your flight unless you want to be prepared for a GPS outage and you know that there's an extra distance to the MON airport. That's up to you and your filing requirements and safety. Last, we have the VOR MON program contact information here at the bottom of the slide. And feel free to contact them with additional questions, but I'll take it over to Leonixa.
Thank you so much, Rick and Vince, for taking our audience to all that very detailed explanation on how the VOR MON was developed and how they can use it. So thank you so much. So we are really looking forward to answering all of your questions. So a reminder, please use the Google link on the comment section of where you're watching the live stream so that we can go ahead and see them and answer as many as we can right now. So with that, we're going to transition to the Q&A. Okay, so right away we have a few questions. I'm going to start with Vince. First question, what is the service volume for a terminal VOR under the VOR MON?
Okay, so a good question, and I didn't really cover that in the slide. The extended service volume to 70 miles is for low and high VORs. Terminal VORs are going to have the same service volume, which is generally 25 miles. Many of the terminal VORs are going away, though, but the terminal VOR service volume will not change.
Thank you. So the next question is for Rick. I'm confused. Do I need a clearance if I lose GPS, or do I just proceed to the nearest VOR?
Excellent question. So you definitely need a clearance for any change in routing. The idea is the controller is going to be very busy, and that's part of the reason we needed it to not require surveillance coverage. So the idea is you would probably make minimal contact. If you've ever flown into Oshkosh, you know they talk real fast, so you don't have a lot of time. If everybody's having a problem, there's going to be a lot of communication going on. So the controller is going to give you a clearance really quick. They might ask what you want to do. If you want to try to take a radar vector, they probably don't have time to radar vector you. So you're going to negotiate whether you're going to try to fly through the outage or whether you're going to try to proceed to a MON airport with them with hopefully minimum communication. But the idea is once they give you a clearance to perform a route that goes VOR to VOR to say a MON airport, you can execute that with minimum overhead.
Okay, so the next question I'll answer. This is about whether this webinar is being recorded. So yes, we are recording this, and you can find it at a later time, anytime, on the FAA YouTube channel. So yes, please rewatch it and also share with people that were not able to join today. Next question is for Vince. I have a non-WAS GPS receiver in my aircraft. Do I have to plan for a MON airport as my alternate?
All right, another good question. So like I covered in the briefing, if you have a non-WAS GPS, you must have an alternate form of navigation appropriate to your route of flight. Now, the good news is if that alternate navigation is a VOR, there will be a MON airport that has an approach that you can file as an alternate, okay? However, there could be other airports that have approaches that you file as an alternate also. So for example, maybe you have a VOR and a DME and another airport is a suitable alternate that has a VOR DME approach. That approach won't be used for the MON because it's got DME, but if you've got it in your airplane, you can fly it. And also there's a part in the AIM which you should look at. Under some conditions, you can file for a GPS approach at your alternate and a conventional approach at your destination. That is also allowed under some circumstances. So the answer is you don't have to plan to a MON airport as an alternate, but the MON airports would be available for an alternate in that case.
Good. So Rick, so how about airliners?
Okay, this is another program that we're very involved with. The idea is it's called Next Gen DME, and we're trying to provide a reliable backup for air carrier aircraft and probably some biz jets that are equipped with this scanning DME concept that's used in a flight management system. And the idea is they can use multiple DMEs to multilat where their position is. And we're trying to make sure that all air carrier aircraft have coverage above 18,000 feet and to the major airports in the NAS. So that may be another little program we do on that. But the idea is we have a plan for the air carrier aircraft that will allow them to navigate through a GPS outage as well.
Well, and also just to add, the air carriers can use the MON too.
Oh, of course. If they're not equipped or if there's a problem, they can use
Right.
the MON as well.
Right.
Thank you, guys. So this one is for Vince. With Galileo, GLONASS, Compass, etc., why is the VOR backup still needed?
Well, you know, we've got all these acronyms, you have to have some more, right? So what's happening with all of these satellite navigation systems, you know, the signals come from a satellite. And you know, there's just not a lot of electricity up there for those satellites. They're all solar powered. So all of the transmitters on the satellites, that's Galileo, GPS, GLONASS, Compass, all of them are very weak signals. And so if we were worried about the GPS constellation going out, yeah, then we could maybe use Galileo or GLONASS or Compass. But what we're really worried about is some kind of interference, and an interference could easily interfere with all of them. So that's why we've gone to the FAA has gone to the VOR MON as a backup rather than trying to rely on another satellite navigation system.
And if I can add to that, it's not just the low power, it's that spectrum is very precious. And so even though there's all those different constellations, they're actually, most of them are all using the same frequencies. So if there was either somebody accidentally or with bad intent trying to take away the service, they could just deny those frequencies to you, and then you would block out all those constellations.
So Rick, this one is for you. In case of a GPS outage, must I go to a MON airport?
No. So the whole idea is the entire MON concept is somewhat optional on your part. The idea is we want to make sure that you have a safe backup of an approach that you can do that does not require those facilities. However, if you happen to be, say, in the middle of the night and you can get a radar vector to the nearest airport or radar vector out of the outage because they're not that busy, then go for it. Also, if you have ADF or DME, then maybe there's more airports that you could do approaches to. So there are all sorts of possibilities when you're actually in the scenario. But what we're trying to do is make sure you have at least an airport that you can get to with minimum equipage during a GPS event.
So Rick, on the same topic, on approaches that will be served by the VOR MON, ILS, localizer VORs, how will waypoints be identified? Marker beacons?
So there are some marker beacons left in the NAS. We have removed quite a few of them, but there will be marker beacons. The idea is that's why we're keeping those additional VORs. Those additional VORs are going to identify those initial, final, and missed approach points. The intersection of the VOR and the localizer, or multiple VORs, identify those points, or maybe it's the VOR itself that's, say, a missed approach point. So that's how you're going to identify those different points from either the VOR itself or VOR intersections.
So this is also for Rick. Seeing a lot of DMEs left in where VOR DME used to be, why is that? And are the DMEs going to be maintained for the long run?
Yes, the idea is that next gen DME program that's providing service for air carriers and other large jet aircraft that have FMSs will use those DMEs to be able to continue area navigation during a GPS outage. And so we need those DMEs to range off of and provide that multi-lat solution for those larger aircraft.
Could I add something to Rick's point there? In the last few years, I think some of y'all have seen that some of the VORs are not operating. They've got NOTAMs on them and things like that. And obviously a backup that doesn't operate is not a very good backup. So just to add to what Rick said, the FAA is doing a real enhancement on supporting VORs and DMEs as these backup navigation aids. And that we didn't cover that in the briefing, but that's part of the program, the overall program that the FAA is working on.
Thank you. Before I ask the next question, I just want to remind everyone, please keep submitting your questions through the Google link on the comment section. You still have time. So the next question is, where can I find a list of the VORs to be removed? So thank you for asking that question. We have a public website. If you go to faa.gov/go/VOR MON, we do keep that updated. You're going to find a list of the VORs that are targeted for discontinuance, which also includes the VORs that have already been discontinued. We also have the list of VORs that you're planning to retain. So, and remember, this is all only for FAA-owned VORs. So you'll find all the FAA-owned VORs in that list, and you can see whether it's planned for discontinuance or retention. Again, thank you for that question. Next question. How long will decommissioned VORs be depicted on aeronautical charts? I'll give that to Vince.
Oh, okay. Well, all right. So, there's a charting cycle for charts. There's a charting cycle for approaches, and there's a charting cycle for VFR charts. And so getting all that stuff to work when you're actually going to take the VOR out of service is always a challenge. But really what's going to happen is when all of the mitigations of the VOR, so all of the approaches have been either revised or PBN approaches developed, airways decommissioned and things like that, then there will be a decommissioning date for the VOR. Sometimes that date might be before the chart is republished. In that case, there'll be a NOTAM issued. But in general, when the VOR is decommissioned, it's going to go off the chart, at least at the next cycle. But again, like I said, there's a little bit of a challenge there, and some of that will be compensated for by issuing NOTAMs.
So the short answer is it'll be off the chart before it's decommissioned, more than likely.
Hopefully, yes.
Okay, thank you guys. So with that, we have concluded our Q&A session. So thank you for those that submitted questions, and thank you for our experts for answering them. I want to thank you all for joining us today, and I do want to encourage you to come back to the next summer safety webinar from the FAA in 2 weeks. It's going to be about ADS-B. Thank you so much.